Alright, in this video we are going to talk about limit notation. So we are just really trying to get familiar with what the notation looks like and what it means. But let's begin first with the definition of a limit. So right here is the it's actually technically the informal definition of a limit, but it sounds very formal. Given a function f, the limit of f of x as x approaches c is a real number r if f of x can be made arbitrarily close to r by taking x sufficiently close to c but not equal to c. If the limit exists and is a real number, then the common notation is, and we're given here, this limit as x approaches c of f of x equals r. So, that sort of sounds like a complicated definition, but what it's really saying here is if you have a function and your x value is getting closer and closer and closer to a particular number, maybe like 3, so x is getting closer and closer or arbitrarily close to 3, then f of x, or the y value, is going to be taken sufficiently close or closer and closer to the value r. So that's sort of what we'll be looking at, and we'll look at that in much more detail in some of the sections to come. But right now we're really just trying to get familiar with the notation. So for example 1, what I want us to do here is I want us to take this limit notation and I want to write it as a sentence. So what we would say right here, I'm going to sort of point out each part. This LIM is the limit of. So when you see the LIM, that means the limit of. And what is it the limit of? It's going to be the limit of whatever is right here. So the limit of x squared plus 7. And then the last part that we say is right here, as x approaches 5. Now typically that's the order that I say it in. Technically you could say the limit as x approaches 5 of x squared plus 7. You just have a little bit of a grammatical difference there. But if we want to type this in a sentence here, we would have the limit of x squared plus 7 as x approaches 5. As I also said, I'm not going to write it both ways on all these, but you could also say the limit as x approaches 5 of x squared plus 7. So that's just sort of rewriting that sentence there. So let's look at another one. This particular limit, we've got just a function g of x here. This is a very general function. It could be x plus 4, it could be 2x minus 7, it could be the square root of e to the third x plus 4. So it could be any type of complicated equation, but we're just going to call it g of x. And notice right here we have a negative behind that letter a. And so a here is a variable that just represents a number. But that negative behind the number, this is not a mistake. This means that you're approaching from the left. So for this particular problem, what we would say is that this is the limit of g of x as x approaches a from the left. Now, if we had a negative in front, that would be negative a. But the negative behind tells us that we're approaching from the left. Sometimes it's easy to get those mixed up because it's a very slight variation in the notation there. Let's look at another one. All right, notice here we also have a negative behind the 1. So if we want to describe this in words, we're going to say the limit. I'm going to just write it a little differently here just so you can see it both ways. As x approaches 1 from the left of 3x plus 2 divided by x minus 1. So you could also say the limit of 3x plus 2 divided by x minus 1 as x approaches 1 from the left. You can sort of switch those up a little bit. Okay, here's another one. We've got an infinity here. So we would say that this is the limit of natural log of x plus 2 as x approaches positive infinity. The positive is not necessary there. You could leave the positive off and just say infinity, because if we just say infinity, positive is assumed. But I kind of like to put it there just to make sure we're going in the right direction. Okay? What we want to do for these problems is we want to take what is written and write it in limit notation. So we're given a function f where f of x equals the square root of x minus 3. And we want to find the limit of f of x as x approaches 3 from the right. So here we've got a couple ways we can write this. Because they give us both f of x and the definition of f of x, which is the square root of x minus 3, we could write it a couple ways. We could, I don't like red, let's go here. Okay, we could do blue. Limit of f of x, or we could say the limit of the square root of x minus 3. Either one is correct here. Probably the part that's the most difficult to make sure you get right, although this is not terribly difficult. We're going to find the limit of f of x as x approaches 3 from the right. So x approaches 3 from the right, we're going to put a plus behind the 3. Okay, and that would be the same over here as well. Let's try another one of those. We've got to find the limit of the function f of x equals e to the 2x plus 3 as x approaches 9 from the left. So we're going to use our limit notation. We'll start out with our LIM. We can use f of x or e to the 2x plus 3. I think I'll just use the f of x here. And then as x approaches 9 from the left. So as x approaches 9 from the left. And so this could be our notation for this problem. Right? For a function f of x equals x plus 1 over x minus 3, f of x can be made arbitrarily close to 3 by taking x sufficiently close to 5 but not equal to 5. So this is a little bit more complicated wording that we see here, but f of x can be made arbitrarily close to 3 by taking x sufficiently close to 5. So right here, x sufficiently close to 5 tells us that x approaches 5. So that's going to need to go here. The limit as x approaches 5. And the function that we're talking about here is f of x. So we can use f of x, or we can use the expression for the function, which is x plus 1 over x minus 3. But I like to go with the most simple option here. So the limit of f of x as x approaches 3. But one thing we haven't used here is this 3 right here. So excuse me, f of x can be made arbitrarily close to 3 by taking x sufficiently close to 5. So f of x is approaching 3. That means that is the limit of this problem. That's what your y value is approaching. So what you would do for this one is you would say equals 3. Now, in the problems that we had before, we weren't told what the limit was. So we were just writing limit notation here, but we didn't have an answer for the question. It says find the limit of, so find the limit of, where we don't know what the limit is. But in this problem, we know what the limit is. So we are going to put it equal to 3. All right, 8. as x approaches infinity, the value of the function f of x equals 5 over x approaches 0. So for number 8 here, as x approaches infinity, so we know we're going to be doing limit as x approaches infinity. So x approaches infinity. The value of the function f of x equals 5 over x. Again, you can use f of x or 5 over x just to mix it up a little bit. Let's just put 5 over x. And this time it tells us as x approaches this infinity, the value of the function approaches 0. So that means this limit equals 0. Okay. For number 9, it says, as t is made sufficiently close to 6 from the right, the value of a function g can be made arbitrarily close to 2. So this one is a little bit tricky. Notice here you've got a function g can be made arbitrarily close to 2. So the function is going to approach the limit. The variable approaches a value as well. So a function g, that has to be your g of x over here. And it is approaching 2, so that has to be your answer, not what your variable is approaching. And actually, I've made a mistake here because notice we don't have an x in this problem. So instead of calling that function right there g of x, I should call it g of the variable that we have in this problem, which is right here. It's that t. So we would say the limit as t approaches 6 of g of t equals 2. So t is made sufficiently close to 6. T approaches 6 from the right. Oh, I left that off. From the right means we need to put a plus sign right here beside it, behind the 6. And the value of a function g, we've got g of x right there, can be made arbitrarily close to 2. So 2 is the answer for this problem. Okay, that gives you sort of an overview of what you're going to need to do for the little quiz that goes with section 1.2. So there is a quiz in Canvas that goes with section 1.2, so please take that quiz. It is graded for correctness, but you get as many submissions as you want, so you can take it over and over again until you make a 100.